Assalamualaikum warahmatullahi wabarakatuh. We are from the third group. Will present our material under the title Measurement and Data Scale. Subject: Quantitative and Qualitative Research in English Language Teaching. Lecture: Dr. Arkam, MPD. Member of group, I am Musyarrafah as the first presenter and Faridah as the second presenter. Introduction. Measurement is a fundamental element in the research process because it plays an important role in collecting accurate and reliable data. The use of appropriate measurement instruments allows researchers to obtain relevant information so that analysis and interpretation of research results can be carried out correctly. In this context, the selection of an appropriate measurement scale, be it nominal, ordinal, interval, or ratio, really determines the validity and reliability of the data obtained. Therefore, an in-depth understanding of the types of measurement scales and testing the quality of instruments is needed to produce high-quality research. Okay, first is nominal scales. What is the nominal scales? Nominal scale is the simplest and most basic scale of measurement. On this scale, data are grouped into categories or groups with no order or numerical values that we can use to compare the categories. For example, if we were conducting a survey and asked about gender, we might get a response of male or female. In this case, we are simply classifying individuals into two groups, but we cannot say that one group is greater or less than other. Similarly, favorite colors are red, blue, and green. These colors are simple different categories with no higher or lower values. Nominal scales cannot be used for mathematical operations such as addition or subtraction because the numbers are used only as labels to distinguish categories, not to indicate quantity or order. Next, ordinal scale. With an ordinal scale, we begin to introduce an order or ranking, but the distance between the ranks is unknown or unequal. For example, if we were using an ordinal scale to assess customer satisfaction, we might have options such as very satisfied, satisfied, and dissatisfied. We know that very satisfied is ranked higher than satisfied, and satisfied is ranked higher than dissatisfied. However, we cannot say with certainty how much satisfaction levels differ between these categories. Another example is education levels: elementary, middle schools, and high school. We know that high school is higher than middle school, and middle school is higher than elementary school. But we cannot say the exact distance between the levels. With an ordinal scale, mathematical operations such as addition or subtraction are irrelevant. But these scales are very useful in surveys for ranking preference or levels or satisfaction. Next, interval scale. An interval scale is a type of measurement scale that provides information about order and also has equal spacing between values.
That is the difference between 20 and 30 degrees Celsius is the same as the difference between 30 and 40 degrees Celsius. However, an interval scale doesn't have an absolute 0 point, meaning that 0 doesn't represent the absence of a value. For example, on the Celsius temperature scale, 0 degrees doesn't mean no temperature at all. It is just a reference point. Therefore, although we can perform addition and subtraction operations on this scale, we cannot say that 40 degrees is twice as hot as 20 degrees, because this scale doesn't have an absolute 0 point. Another example of an interval scale is the calendar. The difference between the years 2000 and 2010 is 10 years. Just like the difference between 1990 and 2000. But we cannot say that the year 2000 is twice as hot as the year 1000. Next, ratio scale. A ratio scale is the most complete of the types of measurement scales because it has all the characteristics of an interval scale, plus an absolute 0 point. This means that we can perform a wider range of mathematical operations, such as addition, subtraction, multiplication, and division. The 0 point on a ratio scale represents the absence of value. For example, a weight of 0 kilograms means no weight at all. With a ratio scale, we can say that a person weighing 60 kilograms is twice the weight of a person weighing 30 kilograms. Other examples of ratio scales are length in centimeters, volume in liters, or age in years. All of these have a 0 point that truly means nothing or empty. For this reason, ratio scales are often considered the most powerful measurement scales and are often used in quantitative research.
Validity and reliability of measurement instruments.
What is validity? Validity is an important concept to understand in the context of measurement and research. Validity refers to the ability of an instrument to actually measure what is intended to measure. For example, if we want to measure a person's intelligence, the instrument used should actually cover aspects of intelligence, not something else such as general knowledge or technical skills. The more valid an instrument is, the more likely it is that the results obtained reflect the true reality. Therefore, researchers must ensure that the instruments used have been properly validated before applying the results of decision of making or conclusions. There are several types of validity used to test whether an instrument is fit for purpose, including content validity, construct validity, and criterion validity. Each of these types of validity has different testing methods and focus on a specific aspect of the measurement instruments. Okay, as I explained before, there are three types of validity. First, there is content validity, which refers to whether all important aspects of variable are covered in the instrument. For example, if we are creating a test to measure mathematical ability, we should make sure that all the important topics in mathematics, such as algebra, geometric, and arithmetic are covered in the instrument. Content validity is often tested by consulting experts in the field to assess whether the items on the instrument cover the relevant aspects. Second, construct validity. Focus more on how well the instrument fits with underlying theory. For example, if we are using a scale to measuring anxiety, we should make sure that the theory of anxiety supports the items on the instrument. If the theory states that anxiety consists of certain components such as nervousness and physical tension, then the instrument should reflect those components. Finally, criterion validity measures how well the results of the instrument relate to another criterion that is recognized as a standard. For example, if we are creating a new test to measure intelligence, we can compare the result of this test with those of an intelligence test that has been shown to be valid to see if there is a strong relationship between the two.
In addition to validity, reliability is also an important aspect of measurement. Reliability refers to how consistent the results of an instrument are over time. A reliable instrument will produce the same or very similar results when used under the same conditions at different times. This means that if we measure a person's body temperature twice with the same thermometer under the same conditions, we should get similar results. There are several ways to measure reliability. One way is through the retest reliability, which looks at how stable the results are when the same test is given to the same group at different times. If the results are the same, then the instrument has good test-retest reliability. Then there is internal consistency reliability, which measures how consistently the items in an instrument produce similar results. This is often tested with Cronbach alpha coefficient, which indicates whether the items in a test are correlate with each other. Finally, inter-rater reliability is used when there is more than one rater or observer who gives a score to a subject. This reliability measures the extent to which the results given by the raters are consistent with each other. If the results of the raters are similar, the inter-rater reliability is considered high. The first step in instrument development is to identify the variable we want to measure. This could be an ability, an attitude, knowledge, or another factor relevant to the research objectives. For example, if we want to measure workplace stress, we need to understand what influences stress and identify relevant variables such as workload, relationships with coworkers, or work-life balance. The next step is to choose an appropriate measurement scale. Is the variable best measured on a nominal, ordinal, interval, or ratio scale? For example, to measure employee satisfaction, we might use an ordinal scale, whereas to measure weight or height, a ratio scale would be more appropriate. We then begin to develop items or statements designed to measure each aspect of variable. At this stage, we need to be careful to make sure that the questions we create are clear and unambiguous. For example, if we are asking about the frequency of fatigue, we need to clearly define what is meant by often or rarely to ensure that respondents provide accurate answers. The final step in creating an instrument is to conduct a validity and reliability test to ensure that the instrument created is truly capable of measuring accurately and consistently. Without good validity and reliability, our measurement results can be inaccurate and difficult to rely on. After the instrument is completed, we do not immediately use it on the entire population to be studied, but need to conduct a trial first. The trial aims to identify whether there are items in the instrument that are not understood by respondents or may cause ambiguity. This is important so that we can revise the instrument and improve its quality before it is used widely. The first stage in the trial is the initial trial, which is usually conducted on a small sample that represents the target population. The goal is to get input on whether the items that are compiled are clear and can be understood by respondents. If there are items that are too difficult or irrelevant, we need to revise them based on the results of this input. After making improvements, we proceed to the follow-up trial, which is conducted on a larger and more heterogeneous sample to test the validity and reliability of the instrument in more depth. This trial allows us to analyze whether the instrument can be used generally in various conditions and populations. If the instrument shows valid and reliable results in the follow-up trial, then we can say that the instrument is ready to be used for large-scale research. After the pilot is complete, we need to analyze the results to determine whether the instrument has adequate validity and reliability. For validity analysis, we can use various statistical techniques to see whether the items in the instrument correlate well with the total score or with external criteria. For example, to see construct validity, we can compare the measurement results with the underlying theory or concept. In addition, reliability analysis is important to assess whether the instrument produces consistent results. For example, we can use the Cronbach alpha coefficient to see how consistent the items in the instrument are. If the coefficient shows a high number, usually above 0.7, then we can say that the instrument has good internal consistency. If the results of the analysis show that there are items that are not valid or reliable, we need to make improvements to the instrument. These improvements can be in the form of deleting irrelevant items, simplifying the language, or adding new items to measure aspects that may have been missed. The goal is to ensure that the instruments we are truly high quality and capable of providing accurate and reliable measurement results.